All right, so welcome everyone. This seminar will be presented by Irene and I, and it's basically an orientation to Year 11. We're going through general information about the contents, so Year 11 chemistry and physics, followed by study methods that Irene will take you through. This will basically cover active recall and using that over passive recall and how to study for exams. And to conclude, I'll be giving information about scaling and why your internal rank matters at your school. Okay, so I'm the one presenting Year 11 chemistry. What I'll be going through, as mentioned before, is just the contents. Maybe some of you have known me if you're my student, but essentially, I study at UNSW. I do a Bachelor of Advanced Science honors, and I major in chemistry and material science. This is my ATAR, but anyways, I received a UNSW AAA scholarship. That's just a scholarship you get at UNSW for a mark you get. And I'm also a research scholar at UCID in the chemistry department. Okay, so going through the actual contents, in Year 11, you have to cover 4 modules in 3 terms. Module 1, Properties and Structure of Matter. Module 2, Introduction into Quantitative Chemistry. Module 2 is particularly important for Year 12 and for further study of chemistry if you choose to do it at university. So in Module 2, you learn how to balance chemical equations, as well as how to measure the quantitative relationships of reactions. It's just applying numbers to things that we have learned before, things that you have learned in Year 10. Module 3 is Reactive Chemistry, how you can predict the products of reactions. Module 4, Drivers of Reactions. So why are some chemical reactions spontaneous? Spontaneous means that they occur automatically without a lot of prompt. This is an overview, but we'll be going through each module in detail through the next couple of slides. Okay, Module 1, Properties and Structures of Matter. Okay, so you can look through the syllabus, right, and see your dot points, but essentially what it is talking about is using the properties of substances to identify separation techniques. So this one here, in this image, the property that is being used, tested, is density, because oil is less dense than water. Put it in a separating funnel, it can separate. Something else you will learn involves the trends and patterns that exist between chemical elements and atoms. This is where you look at the periodic table, right? An example here is the Pauling electronegativity values. This is an example of a trend of how elements have different pulling power of electrons, because some atoms attract electrons more than others. And through this, through using the previous dot point, you'll learn about different types of bonding. So whether it's ionic, covalent, and you will also learn some intermolecular bonding like hydrogen bonding or, dispersion forces, dipole-dipole. Okay. In Module 2, probably the most important module, you'll learn about different types of chemical reactions and stoichiometry. Stoichiometry basically refers to this reaction coefficient. It is the number to make sure that everything is balanced. You need to make sure that this number is correct, otherwise every calculation you do after will be wrong and you'll get 0 marks for whatever question you do. Also in this module, we make predictions and calculate the mass of reactants and products in every single state. Now, something that's wrong in this equation, if you're my student, you will know, is that there are no states here. You always have to write your states in your equations. So the last thing that we'll learn is concentration, molarity, and gas laws involved in this module. Okay. Module 3, in reactive chemistry, we study a range of reactions. This can include synthesis, decomposition reactions, combustions, as well as reactions involving metals. So reactions involving metals are redox reactions. They are characterized in terms of electron transfer. So you have one element, it either loses a couple of electrons or takes in a couple of electrons, right? And these reactions have an electrochemical potential, which we will calculate using a formula. Lastly, how the rate of a chemical reaction can be affected by a range of factors. So the range of factors will be temperature, pressure, etc. Anything that affects the rate of a reaction, like catalysis, using a catalyst lowers the activation energy, it improves the speed of a reaction. Okay. Module 4, drivers of reactions. Here we will study what energy changes occur in chemical reactions. And the couple of parameters that we will use to characterize these systems is enthalpy and entropy. These will be used to explain reaction spontaneity. Reaction spontaneity refers to whether a reaction spontaneously proceeds forward. All right, so whether it moves forward without a lot of prompt. And we use Hess's law and Gibbs free energy to calculate exactly. So if delta G is negative, the reaction is spontaneous. We can see that in delta G, we have enthalpy, H, and entropy, as well as temperature. So here you'll learn how to use Gibbs free energy to calculate reaction spontaneity. Oh, also, if you have any questions, just put them in the chat and I'll see if I can help. All right. In the syllabus, in the curriculum, there is a compulsory section you have to do. It's called the depth study. It's 15 hours of independent study. Obviously, your school cannot monitor whether you've done it independently or not. So if you have a tutor, you can ask them whether you're doing it correctly. But what this is that your school will give you an assessment task. They would generally ask you to identify an issue or phenomena in chemistry. Right? This is something your school either assigns to you, or if they really want you to be independent, they will make you choose a topic. Then you have to conduct an investigation and collect data. So what I mean by conducting investigations, it's usually just researching online, like in a literature report, but sometimes some schools will make you actively write out a method and make you actively collect the data. In that case, it does require a bit more planning. So once you have your data, you have to analyze the data, you have to draw conclusions from what you have and communicate your findings. When you communicate your findings, it's usually in a presentation or a report, whatever your school chooses. But this is a compulsory bit and it's usually worth like 20% at schools. It differs. All right, so as a depth study, I'm going to go through the types of questions you might see in exams. Okay, so you have your factual questions. These are the most basic questions that you'll get. Usually it's just to test whether you have remembered something. They usually recall questions. So to define something, it might be a very simple calculation, very simple, just recall a formula. But these are the most simple questions, maybe worth 1 to 2 marks. Next types of questions in chemistry, calculations. Now, calculations are identified by having numbers in the question. These prompt you to recall the relevant formula, make sure you write all your working out, and make sure, in chemistry at least, to report your working to the correct significant figures. This is very important in chemistry and in physics, as we will later find out. If you don't report it to the correct significant figures, the accuracy of your results will be wrong. All right, it's very important in science to have the correct accuracy. All right. And the last type of question that you might get, this would be 6 to 8 marks. These are your analysis questions. Okay, analysis questions are long form questions. You are usually given a prompt, like some sort of stimulus in your question, and you're asked to draw a logical conclusion. These are very long. They test whether your writing skills are good. So analysis questions, they're probably the most challenging in my opinion. Okay, common student issues. When answering exam questions, a lot of students don't follow HSC verbs. The HSC verb, you can search on NESA, but the HSC verb is the first word of the question that actually tells you how to answer the question correctly to get full marks. A lot of students, they get stressed out and they don't read the first word. They just try to figure out what they have to do, but they don't rationalize how they're supposed to answer. So even if they know the concept, if they don't follow the HSC verbs, there is no way that they will get full marks. Another common issue in chemistry is rote learning. Failing to understand concepts deeply means that you can't answer harder questions. So going back to the balancing equations example, you're not going to remember, or I hope you shouldn't like memorize, you're not going to remember the exact perfectly balanced form for every single equation in existence. You have to know the most efficient way to balance equations as possible, because in an exam, you don't want to waste time like rubbing out your coefficients. And calculations. There are so many things that can go wrong when you're doing calculations. So just to list out some common student errors, they didn't balance the equation properly. They picked the wrong formula, wrong significant figures, and rounding too early. If you round too early, then your final answer would be slightly inaccurate. Or during an equation, they didn't pick the limiting reagent correctly. We will learn more about what a limiting reagent is in module 2, and they also have messy working out, which means that the marker struggles to find where the correct answer is. And you know, if the marker is marking like 200 students, you want them to see the answer as fast as possible. You don't want them to get frustrated. Okay, so most important concepts leading into year 12. Okay, so around 30% of year 11 content directly feeds into year 12. Probably out of that 30%, maybe like 20% is module 2, and 10% is like general knowledge. So the most important bits, moles, balancing reactions, and skill in calculations, right? What I mean by skill in calculations is just the logical progression of thought that goes into your calculations. That carries over in year 12. Also in year 12, you'll be studying organic chemistry, and you need to know the difference between intermolecular bonding and intramolecular bonding, because knowing the difference in that means you can predict some properties that organic chemistry in year 12 requires you to. Okay, so for year 11 physics, I'm going to pass it on to Irene, and she'll be taking you through this.
Okay, thank you, Carmen. Hi guys, thank you for joining us today. I'm going to talk to you about year 11 physics first. So before we get into it, oh, Carmen, can you give me access?
Oh, yes, I do have to give you access. Yeah, is it working now? Joys of Zoom.
Yes, okay. So my name is Irene. I am a senior tutor for science at OpenWisdom Education, and I also study optometry at the University of New South Wales. So let's get into this. So this is an overview of preliminary physics. There are 4 modules, just like in chemistry, and the modules are kinematics, dynamics, waves and thermodynamics, and electricity and magnetism. So we're going to start with kinematics. You guys probably already do kinematics if you do physics. So it concerns motion. You're going to learn everything that you need to know about motion in a straight line, both vertical motion and horizontal motion, and also the differences between the two. And you're going to look at scalar quantities and vector quantities. Then module 2 is dynamics. In dynamics, you analyze motion, but you also include forces and energy changes. So you're going to see how forces affect objects' motions. You're going to predict the motion of objects after a collision, and also the energy changes after a collision. And you're going to look at Newton's laws of motion. Module 3 is waves and thermodynamics. So this module is all about energy transmission, so including heat and sound, as well as waves in the ocean. So you're going to learn about the different types of waves and their properties. You're going to learn about the features of waves and how they affect our perception, as well as how energy is transferred. And lastly, module 4 is electricity and magnetism. As you can probably guess, it's about electricity and magnetic fields. So you're going to learn about how electric fields interact with charged particles, how magnets interact with each other. And a big part of this module is electrical circuits. So you will learn the different types of circuits and how to set them up. All right, so some student issues in physics. First of all, students tend to learn the content and then do a couple of questions that they find easy and then move on to something else because they feel like it's too easy for them. This is a big mistake. In physics, you have to keep doing questions no matter how easy you find it, because if it's too easy, it probably means that you haven't found hard enough questions yet. The second mistake is students confuse being familiar with the concept with understanding the concept. And we're going to touch on this in a little bit in more detail. And lastly, calculations. Physics has a lot of calculations, as you can imagine. A big mistake in calculation-based questions is not showing your working out. And this is a really big mistake because if your working out is correct, and say you plug in the wrong numbers in your calculator by accident and you get the wrong answer, you may get marks if you show you're working out and it's correct. But if you just write the wrong answer without any working out, you're not going to get any marks. Second mistake for the calculations is rearranging formulas before you substitute the values. So usually you get a mark just for using the correct formula, but if you use the correct formula, rearrange it wrong, and then plug in the values, you actually didn't use the correct formula, so you wouldn't get a mark there. And lastly, you have to make sure that you convert everything to SI units before you do any calculations. So the most important concepts leading into Year 12, pretty much everything from kinematics, dynamics, and electricity and magnetism is going to be in Year 12 as well. So you need to know those really, really well because they are going to be assessed. And most of the formulas that you're going to use in Year 11 are also going to be used in Year 12. A skill that you really need to master in Year 11 in physics is understanding when to use positive and negative values in your calculations, because if you ignore a negative sign, it's going to give you the wrong answer. All right, so in this section of the seminar, we're going to talk about how you can study for science. We're going to start with ineffective learning, and hopefully you can identify some mistakes that you might be making. So let me introduce you to passive learning. Passive learning is an umbrella term for any study method that doesn't involve testing yourself. So that's, for example, listening to your teacher explain something to you, or reading a passage, watching a video, and all of those are great, but the problem is when it's the only study method that you use. So passive learning is extremely ineffective as a study method if it's the only method that you use. And unfortunately, a lot of students only use passive learning, which is why I am talking about it today. So some examples of ineffective applications of passive learning are copying notes from your textbook without understanding the content first, rewriting notes to learn the content, so if you don't already understand the content, and rereading a passage again and again for the purpose of memorizing it. So why is passive learning ineffective on its own? First of all, it is extremely time-consuming. You can imagine that if you rewrite notes again and again for the purpose of memorizing them or for the purpose of learning them, it's going to take a lot of time that you could have used otherwise. The second problem is it only provides surface level understanding. It's very much impossible to build a deep understanding of anything just by reading about it or just by hearing about it. You have to engage with it more deeply. And third, it creates a sense of familiarity with content. But why is that a bad thing? Oops. Recognizing an idea is not the same as understanding it. Recognizing an idea is when you may hear the words relative velocity and think, oh, I know that, I did it at school. But if you cannot explain it, you don't actually understand it. You're just familiar with it. So familiarity is only the first out of many steps in learning, and it provides a false sense of mastery. This is especially important if the only study method that you've ever used is passive learning, because then you don't know how much deeper your understanding can get. So let's talk about the best study methods now. These are the 4 steps that you need to follow to learn anything. All of them are equally important and you cannot skip any of them. So we're talking about familiarizing yourself, understanding the content, applying it, and then revising. So to familiarize yourself with the content, you have to use passive learning. So as I mentioned, passive learning is not a bad study method. It's only bad when you use it by itself. So the goal here is for the content to make sense. You have to engage with the content without actually explaining it or applying it yet. So how do you apply passive learning? you break down the content into short sections, because if you try to learn all of it at once, you're going to overwhelm yourself. Gather a variety of resources. That could be textbooks, videos, your teacher explaining it to you also is a resource. And engage with the content slowly and carefully, and ask someone to explain it to you if you still don't understand it. So that could be a teacher or a tutor, preferably not someone that is learning it now with you, but someone that already knows it. So once you're familiar with the content, you can move on to step 2, which is active recall. In step 2, you want to figure out what it is that you don't know, and you want to understand the content more deeply. So what is active recall? Active recall relies on your memory to explain something and to answer questions. And what it does is it tests your understanding as you go. So instead of reading something, you have to think about it. And how do you apply active recall? There are many ways to apply it, but the common factor across all of them is that you have to do it without any assistance. So don't look at your notes, don't watch any videos when you try to apply this method, just rely on your memory. So some examples of ways that you can apply it is by explaining the content to yourself or to a tutor. You can ask yourself relevant questions and answer them. You can write notes explaining what you know, again, without any assistance. So don't copy the notes from your textbook. And presenting the information in a table or a diagram. This last point is especially helpful for physics because oftentimes in exams, they may ask you to draw a diagram of a process. And it's going to be really useful if you do that for practice at home anyway. So if you struggle with any of these, it means that you're not familiar enough with the content and you have to go back to step 1, which is passive learning. So once you can explain the content well, you can move on to step 3, which is practice questions. So this is when you actually apply your knowledge. So the goal here is to learn how to formulate answers and challenge your understanding. You can find practice questions everywhere, pretty much online. Some examples here are OpenWisdom booklets, questions that your tutor makes up, past papers, textbooks, and online resources. And how do you apply this method? You have to get feedback on every single question that you do. If you do a question and you don't get feedback, there's really no point in doing it because you don't know if you did it correctly or not. After you receive feedback, always rewrite your answer. Don't just annotate it because you're going to forget it. But if you write it out again, you're more likely to retain the answer. Avoid multiple choice questions initially. Multiple choice questions should only be done at this stage if you can answer them without looking at the options. So if you have to look at the options and choose an answer, that doesn't actually test your understanding. It tests your familiarity with the content. So keep that in mind. Attempt a variety of question types. So that includes short answer, long answer, calculation questions, graphs and diagrams. Reattempt difficult questions after a few days until you find them easy. This is very, very important. If you do a question and you find it difficult, come back to it like a day or 2 later and then do it again. If you still find it difficult, do it again like 2 days later. Obviously, this implies that the first time that you attempted it, you actually answered it. If it's so difficult that you cannot answer it, just take it to your teacher or to your tutor, and they're going to help you with it. And lastly, when you do questions, show all working out. So that's good for, it's good for practice because in exams you have to show all of your working out, but it also helps because if a month later you don't remember how to do the question, you can go back and look at the working out and remind yourself. And step 4, which is revision. This is the study method that you use to revise. So this is spaced repetition. The goal is to move information from your short-term memory to your long-term memory and to reduce stress by spreading out your revision. So you can see a graph here. On the first day that you learn something, you have 100% memory retention of it. But a day later, it drops down to 80%. So by revising the content after 1, 3, and 6 days of learning it, you can see that the decline is much slower, which means that the information has gone into your long-term memory. A way that you apply spaced repetition may be with flashcards, also active recall. So you can ask yourself on the 3rd day and the 6th day you can just explain it to yourself. And you can also do questions. So all of those count as spaced repetition. But simply rereading the passage again and again after 1, 3, and 6 days is not considered spaced repetition because it doesn't actually, it doesn't engage your memory. So how do we apply these study methods at OpenWisdom? So for passive learning, we obviously explain the content to our students, and we also have booklets with theory that cover all of the content that you need to know. For active recall, we make up questions for the students to answer, and we ask students to explain the content to us, and then we provide feedback. For practice questions, we have a lot of practice questions that we give our students. Every booklet that we have has questions in it, and we also have designated booklets with homework questions. And for spaced repetition, every booklet that we have has a quiz at the beginning, and you just test content from the previous week. So how do we apply these methods in chemistry and physics? So in physics, this is just a drawing from the Kinematics module. Calculate the relative velocity of 2 objects moving along the same line using vector analysis. So on the first day that you learn about this, which is day 0, you would familiarize yourself with relative velocity and then try to explain it to yourself. And if you struggle, you go back and review it. On day 1, which is the next day, you ask yourself questions about relative velocity. And you want to see if you can still explain it. If not, you go back, you read about it again, and you try again to explain it. Also on day 1, you can start answering questions. And then on day 3, you try to explain relative velocity to someone else. So explaining it to someone else is a bit harder than explaining it to yourself, because when you explain it to yourself, you tend to be a bit more linear. So when you explain it to someone else, you're a bit more serious about it. And you also attempt more challenging questions on day 3. And then on day 6, you can do past paper questions. If at any stage you struggle, then you go back to day 0 and you review the content, and then you revise again after 1 day, 3 days, and 6 days.
Okay, for chemistry. Oh, yeah, thank you, Irene. So for chemistry, it's pretty much the same process. The general idea is you're learning the content on day 0, and you're reviewing the content at these regular intervals, day 1, day 3, and day 6. So day 0, you familiarize yourself with the start point, which is redox reactions, electrochemistry. Day 0 is what you learn it in school, you learn it in class, or you teach it yourself. It's just the first day you encounter the content, right? And by the end of the day, you've probably forgotten everything. So the next day, you review that content again and explain it to yourself. So what is a half equation? How do you balance these half equations and add them together to get an overall equation? And you might do practice questions that your tutor gives you, or just get them from the textbook or other OpenWisdom resources. Day 3, you do the same thing. You probably would have forgotten about half of the stuff. So an example of recalling the information, as Irene has talked about, active recall, you can explain redox half equations to someone else. Generally, try to explain redox half equations to someone who knows what redox half equations is, so they can correct you, like a tutor. And you can attempt more challenging questions. Day 6, I put here past paper questions, but I would save past paper questions until you're totally confident with them. So you don't waste any past paper questions, or just do the past paper questions when you are certain that you have an exam on it. But really, it's just study the content at regular intervals, increase the difficulty at each interval until you become extremely familiar with it. So that's just for chemistry. All right, I'm also going to go through why your internal rank matters in school. So year 12, at least, once you go into year 12, you have 4 assessments because you have 4 terms, okay? And after these 4 assessments, you have your external exams, your HSC exam, okay? Assessment 1 to 4, your result in these gives you your subject rank in school. This is what maybe a tutor refers to when they ask you like what your rank is. It's just like whether you're first, second, third, etc. in school. So 50% of this comes from subject rank and 50% of it comes from your HSC. But your HSC mark is your HSC assessment mark plus what you receive in your exam, and you average it, you divide it by 2. Okay, so this is why ranking is important. It makes up around like 50% of your HSC mark. Okay. NESA ignores your school mark because each school has its own exam papers which are different to other schools. If it's a good school, they would create exams that suit the difficulty of the students. So for example, if a student got 50% in James Roos compared to a student that got 70% in, say, a school ranked in the 500s, this doesn't necessarily mean that the 70% student at the lower ranking school is better than the James Roos student just because they got high in their own exam. This is why NESA ignores the school mark. So as mentioned before, difficulty will vary across different schools because there are different caliber of students. If NESA did take the school mark, then every school will reward its students with 199.98 because they want to give the students the best mark, the best ATAR. Okay, so this is how your internal rank works. Assessment 1 to 4 in year 12 final report, you get a mark, a ranking, according to how you performed relative to other students. So student A got 100%, they ranked first. Student E, 70%, they ranked last in this group of 5 students. Okay, so just looking at the first one, student A, mentioned before, they got 100%. They ranked internally, they ranked first, and when they did their HSC exam, their external exam, they got 95. Their moderated assessment mark is 95 because they ranked first. So what NESA did is that they took the exam mark and that was their internal mark, right? And they averaged it to get what the HSC mark. So this first number here, this first 95 is their internal mark. Second 95 is the mark that they received in the HSC. You average it, you get your HSC mark. Okay, student B, they got 93, which means that they came second. Student C got 90, which means that they came third. Looking at the corresponding HSC marks, student B only got 80, while student C got a band 6, they got 90. What NESA does is they take into account your internal rank. So student B essentially steals student C's exam mark, and their moderator mark is now 90. So they took student C's higher mark because they ranked second. And when you average it, they got 80 in the exam, but their internal mark is 90. Average it, they get 85. Student C, they ranked third, which means that they take the third highest HSC exam mark, which means that they get 80, right? And when you average it, you get 85 again. Okay, and student D and E, pretty self-explanatory. They ranked 4th and 5th, and the HSC exam mark got 70 and 60. They moderated, and this is the average. This can be quite confusing. So does anybody have any questions so far? No? Okay, well, you can ask at any time if you do have questions. Okay, so subject scaling. All right, so we have a bunch of subjects here. Everybody got 90. But if we look at English Advanced, a 90 scaled down, all subjects scaled down, but bad scaling subjects scale down significantly more. Only Extension 2 math scales up. I think Classical Greek, maybe. But anyways, English Advanced 90, it gets scaled down to 83. If you look at the other English course, English Standard, you have a HSC mark of 90, that gets scaled down to 83.4. So it gets scaled down a bit more. If we look at Maths Extension 1, getting a 90 only scales down 2.5. In General Maths, get 90, it scales down all the way to 76.1. So you can see that Maths Extension 1 is more difficult, so it gets scaled better than General Maths because it's much easier to get a good mark in General Maths than it is to get in Maths Extension 1. Okay. So going back, this is what happens when students did really well. They pretty much got a band 6 in every subject. But if you didn't, if you get a band 5, mark of 80, your ATAR is slightly lower and scaling becomes a much bigger factor. So English Advanced, yeah, sure, it gets scaled down to 64. English Standard gets scaled down to 60, so it's a much bigger bracket. Maths Extension 1 gets scaled down to 77.8, while General Maths gets scaled down to 62. And if you notice, the ATAR difference between these band 5 students is much greater than the ATAR difference between these band 6 students. So what you can conclude is that even though you might do low scaling subjects, it's okay if you do really well in them. Like these subjects are low scaling, but this person here got pretty close to 98, right? Because they got all band 6. So scaling matters less if you do very well in the subjects. Okay, so just to illustrate this, as I mentioned, Extension 2 Maths is probably the only subject that gets scaled up, maybe, but it gets scaled up. Most subjects get scaled down. So if you get a mark of 78, Extension 2 Maths gets scaled up to about 81. Everything from like chemistry to business studies, it gets scaled down, but as you can see, chemistry is, according to NESA, more difficult than business studies. So they give the students studying chemistry a bit of an advantage by giving the subject better scaling. This is why you might see some schools push the harder scaling subjects, like they might not offer English Standard, they might just offer Extension 1 or Extension 2 Maths because they want the students to get the highest ATAR because of reputation, you know. So that's scaling. Okay, so the subjects we offer here at OpenWisdom: Maths, we do Maths Advanced, Extension 1 Maths, Extension 2, and Standard. In science, chemistry, I do chemistry, and physics, which Aaron does. I also teach biology, but yes, we offer chemistry, physics, and biology. English, EALD, Standard, Advanced, Extension 1. Others include business studies, economics, and we also have some Japanese tutors here. Okay, so if you're new, you're not with OpenWisdom yet, if you're interested in booking a free trial lesson in term 1, you can contact through the internet, right? You can contact through the website. You can email OpenWisdom directly, but when you do, please email your name, school, contact number, or subject of interest, because we have to keep track of all our students. Or you can contact us directly through WeChat. Our WeChat ID is OpenWisdom HSC. If you're not with us right now, it's a free trial lesson. It doesn't hurt. If you don't like it, you don't pay for it anyways. So you get like, it's completely free. You can at least try it if you want. So that concludes our presentation. That was supposed to be a seminar, but thank you for attending, everyone. If you have any questions, now is the time to ask that. You can turn on Facecam, voice, or just type in the chat if you want. Does anyone have any questions? All right, well, if no one has any questions, if anyone does have any questions, just email James, OpenWisdom, at this email, and he'll ask us, and then we can refer back to him, and you know, he can be the mediator, essentially. So if you have any questions, just email OpenWisdom. But right now, if no one has any questions, that concludes our presentation. So thank you all for attending. All right. I'm going to stop share.
Thank you, guys.
Thank you.